Back in the day, joining two pieces of metal meant welding them together and hoping that seam would hold under pressure. But what we're watching here at Karl Diedrichs in Germany is something far more remarkable. The creation of seamless rings, pieces so perfectly formed, they have absolutely no weak points. These aren't your everyday metal rings, folks. We're talking about components that'll end up in massive turbines generating electricity for entire cities, or precision bearings supporting aircraft engines at 30,000 feet. The process starts with forged blanks that have already been shaped under enormous pressure. Now comes the real artistry. Watch as these pre-forged pieces are heated to precisely the right temperature, not too hot, not too cold. The massive ring-rolling mill grabs hold, and through a carefully choreographed dance of pressure and rotation, gradually expands that solid piece of steel outward. No cutting, no welding, no seams whatsoever. The beauty here is in the metallurgy. By forming the ring this way, the grain structure of the metal flows continuously around the entire circumference, creating strength that a welded joint simply cannot match. Now, if you've ever wondered how those beautiful aluminum wheels on modern vehicles get their precision-cut spoke patterns, you're about to witness something truly remarkable. We're looking at the Datron M8 Cube in action, and folks, this German-engineered marvel is revolutionizing how manufacturers create 12-spoke aluminum rims. The Datron M8 Cube isn't your grandfather's milling machine, though he'd certainly appreciate its craftsmanship. This high-speed machining center operates at spindle speeds, reaching up to 60,000 RPM. That's about 20 times faster than traditional mills from the 1970s and 80s. What makes this particularly fascinating is the machine's ability to maintain incredible accuracy while moving at these tremendous speeds. Watch as the process begins with a solid aluminum blank being secured in the machine's precision fixture. The Datron uses what's called a direct drive spindle system. There are no belts or gears to wear out, just pure direct rotational power. This means less vibration and cleaner cuts, something old-school machinists would have given their left arm for back in the day. The cutting tool, a specially coated carbide end mill, begins carving out the first spoke cavity. Notice how the coolant floods the cutting zone? This isn't just for cooling. It's washing away aluminum chips at high velocity to prevent them from recutting and damaging the surface finish. The machine follows a CAD program toolpath with precision down to 5 microns. That's thinner than a human hair. What's really impressive is the machine's linear motor technology. Unlike traditional ball screws that move the cutting head, these linear motors provide faster acceleration and positioning. The M8 Cube can change direction instantly, allowing it to cut those smooth, flowing curves between each spoke without any hesitation marks. As we watch each spoke take shape, the machine is simultaneously monitoring tool wear, adjusting feed rates, and compensating for thermal expansion. The entire 12-spoke pattern is completed in roughly 15 minutes, a job that would have taken hours of manual labor just a generation ago. The final passes create that mirror-like finish you see on premium wheels, all without any secondary polishing operations. This is modern manufacturing at its finest, blending speed, precision, and efficiency in ways that honor the craftsmanship of the past while embracing the technology of today. Here's a piece of equipment you don't see every day. OHA Corporation's CBM12 chain bending machine. And it's solving a problem that's challenged manufacturers for decades. How to create perfectly formed chain links quickly and consistently. The CBM12 uses a clever servo-hydraulic system that old-time blacksmiths would marvel at. Watch as the steel wire feeds into the machine at a controlled rate. Those precision rollers you see? They're made from hardened tool steel and guide the wire exactly where it needs to go. The bending head contains multiple forming stations. As the wire advances, it's first pre-bent to remove any inherent curve from the coil. Then, the main forming dies engage. Notice how smoothly they rotate and press? That's hydraulic pressure providing up to 40 tons of force, yet controlled so precisely you could bend a paperclip without breaking it. What makes this particularly impressive is the machine's ability to create complex chain patterns. Those programmable servo motors adjust the bend angle and radius on the fly, allowing one machine to produce everything from delicate jewelry chains to heavy-duty industrial conveyor links. The CBM-12 can form up to 120 links per minute with consistent quality. Temperature sensors monitor the forming dies because even a few degrees of heat buildup can affect the steel's properties. This level of automation and precision has transformed chain manufacturing from a labor-intensive craft into a highly efficient modern process. Welcome to one of the most impressive concrete production facilities you'll ever see, a Vollert Anlagenbau system that's manufacturing the concrete railroad ties that form the backbone of modern rail networks worldwide. Vollert, a German company with roots going back to 1925, has perfected this process into an industrial symphony. It all starts at the batching plant, where limestone aggregate, Portland cement, and precisely measured water combine under computer control. The concrete mix for railroad ties is special. It needs to be incredibly dense and strong, capable of supporting freight trains weighing thousands of tons. Watch as the long line casting beds are prepared. These beds, stretching over 400 feet long, are first cleaned and coated with a release agent. Then comes the pre-stressing operation. High-strength steel cables are threaded through the entire length and tensioned to exactly 200 pounds per square inch. This pre-stressing is what gives modern concrete ties their incredible strength and resistance to cracking. The concrete pouring system moves along these beds like a precision machine, filling each tie mold cavity with exactly the right amount of material. Notice those vibrating tables? They're running at specific frequencies to eliminate air pockets and ensure the concrete completely fills around the pre-stressed cables and the tie plate inserts. Here's where it gets really interesting, the curing process. These ties enter climate-controlled steam chambers, where temperature and humidity are precisely regulated. Over the next 8 to 12 hours, the concrete reaches about 70% of its final strength through accelerated curing. This is the same principle used in precast concrete construction since the 1950s, but refined to perfection. After curing, an automatic saw cuts the long bed into individual ties. The moment those cuts are made, the pre-stressed cables are released, and that tension transfers into the concrete, creating compression forces that help the ties resist the constant pounding of train wheels. The finishing station is where quality control happens. Automated systems check each tie's dimensions, test for internal defects using ultrasonic sensors, and verify that the tie plate inserts are properly positioned. Step inside the legendary factory in Sant'Agata Bolognese, Italy, where Lamborghini has been handcrafting automotive dreams since 1963. What you're seeing is a beautiful marriage of old-world Italian craftsmanship and cutting-edge manufacturing technology. The process begins with aerospace-grade carbon fiber being laid up by hand, yes, by hand, on precision molds. Each layer is carefully positioned by skilled technicians, then the entire assembly goes into an autoclave where it's cured under heat and pressure, creating a structure that's stronger than steel yet lighter than aluminum. Watch as the carbon fiber monocoque chassis emerges. This single-piece construction method was pioneered in Formula One racing and provides incredible rigidity while keeping weight to a minimum. Those technicians are using specialized ultrasonic testing equipment to verify the integrity of every square inch. The famous V12 engine assembly is equally fascinating. Each engine is hand-built by a single master technician whose signature plate will stay with that engine forever. Torque specifications are measured to the exact Newton meter, and every component is balanced to racing standards. Notice the marriage station where the engine meets the chassis. It's like watching a precision ballet. Custom-fitted body panels, hand-stitched leather interiors, and that final paint process in climate-controlled booths ensures each Lamborghini is truly a rolling work of art.